Hi, this is Ms. Haney. I'm just making this video to explain a little bit more about how to identify key features of a graph. So whenever you're given a graph and asked to identify the key features, the first thing that you're going to want to do is identify where the x and y intercepts are. So the x-intercept is going to be any point or points that cross the x-axis. And if you remember, this is our x-axis. So it looks like we have one here, here, and here. Hopefully I got them all. So we want to make sure that we write down the x value. It's your decision if you want to just make a list of the x values or if you want to actually write them as ordered pairs. So let's start with this point. It looks like it's -1, 2, 3, 4, and a little bit more. So we'll say it has an x-intercept at maybe -4.25. And I'm going to say comma 0. So that's the ordered pair. If you just wanted to write -4.25, you would not have the parentheses. All right, the next x-intercept, I'm going to say that's close enough to -1. And then the last one is over here at +3. All right, the y-intercept is where it crosses the y-axis. And it looks like this doesn't really have any notches on the y, so we'll maybe make some up. Let's say there we go. All right, you'd always be given one that has a scale. So the y-intercept, like I said, is any point that crosses the y-axis. This crosses the y right here. So we're going to say that is at -1.5. So the y-intercept would be 0, -1.5. And notice that the 0 has switched positions between the x and the y-intercept. All right, the next thing that you're going to want to do is try and find any relative maximums or minimums. So maximums you want to think about as being the top of a roller coaster curve, and the minimums would be the bottom. So if I'm traveling along my function, there's a maximum, and it looks like really that's the only one. You might think this is a maximum. However, if this is a perfectly flat line, then this wouldn't be the top of a hill. It would just be, you know, it's flat. So really this only has one maximum. And it looks like it is at -1, 2, 3. With my new scale, let's say it's at +2. So -3, +2. All right, minimums are any point where it's at the bottom of a roller coaster hill. So I would say that we have a minimum right here, and that order pair would be 1, -2. The next thing you probably want to think about is the increasing and decreasing. So remember, for increasing and decreasing, you want to put yourself on the leftmost part of the graph. So here's a little Honey, I Shrunk the Kid size me. If I were to walk along this function, the first thing I would be doing is increasing. And when we're talking about increasing and decreasing, we're only talking about the x values. So since these are my negative numbers, I'm actually increasing from -infinity, because that arrow means it's going on forever. So I'm increasing from -infinity until I get to this point right here, which is at -3, +2. But remember, we only care about the x value, so the x value at -3, +2 is the 3 right here. So -3. From this point, we start decreasing. If I were to walk along here, I'd be decreasing, and I'm decreasing until I get to this minimum value here. And remember, you can write down the ordered pair if that helps you. So I would say this is 1, -2. But the only thing I care about for increasing and decreasing are those x values. So that would be 1. So I'm decreasing from when x is -3 until x is +1. From here, it keeps going up until we get to this x value. So now it's increasing again from 1 until 1, 2, 3, +4. At that point, it levels out. Of course, my lights would turn